Hello, everyone. My name is Alex Bortok, product manager at Keysight. So I'm going to talk about performance of the backend fabric in the AI clusters today. All right. Quick overview: what Keysight does. We create solutions for companies that build products. It could be a microchip, smartphone, router, 5G tower, or AI data center. We help them to move from idea to prototype, from prototype to a real product, and then understand how this product works in production, accelerating their life cycle of these products. Now, in AI data centers, a lot of you already know there are at least two types of the networks. There's a front-end network, and my colleague Amritam presented today a solution called Keysight Sideperf that is well positioned to test front-end networks. And our customer Crusoe told us this story how they use that product. I'm going to talk about a different product called Keysight Data Center Builder, and that product is used to test backend networks. The backend networks are those that GPUs use to exchange data, mostly during model training, but also nowadays during the inference as well. And so my talk going to have two parts. So in the first part, I'm going to introduce the Keysight Data Center Builder product. And then in the second half, I'm going to show you a demo of that product. And I'm going to end up with a real use case of fine-tuning the performance of the data center network. So stick around if you are watching live. And if you are watching this video, make sure to go and look up for the second video part, which is going to be the demo. All right, so what the Keysight Data Center Builder does, it emulates AI workloads so that you can benchmark performance of the network infrastructure, figure out how you can fine-tune the performance for them to perform better, reproduce issues you see in production, and also plan for new designs, new topologies, new generations of those networks, and understand how they would behave at scale. We do all of that by emulating behavior of the real GPU server, so you don't have to buy those for your lab. What kind of customers need that type of benchmarking? So we have three very established categories of customers. First of all, it's large-scale AI operators, as well as GPU cloud providers. The second is the network vendors that make routers and switches and all that kind of stuff. And then, of course, the silicon vendors that create, ASIC silicon and that goes into the switch or a NIC, or very often nowadays into a GPU as well. Now, how does it apply to your company? Well, if you, for example, have a performance issue with the GPU cloud, you might very well benefit from using our product to understand where these performance problems are coming from. Also, if you're building your own GPU cluster and it has scaled at least 128 GPUs, you might, be in the position to already benefit from using this testing solution. And then finally, if you're thinking of buying GPUs to have them in your lab just to run network experiments, just consider alternatives. You probably will find better use for those GPUs. All right, so let's talk about why using GPUs to test and benchmark is not the best idea. So obviously, they cost a lot and hard to get. But now, if you are an engineer who is focused on the infrastructure, especially if you're a network engineer, running end-to-end system with GPUs and software stuck on it comes with a lot of complexity. You have to learn a lot of things that you actually never learned before. So that stands between you and achieving your goal of, having network to perform the best. And now, even if you figure out how to use, nickel tests, not that hard. Maybe you figure out how to run MLPerf, much harder. But in any case, when you run them and then you collect data from different parts, you actually don't know how to correlate them. So you see some performance, values from the MLPerf. And then you see some metrics from the network or a network card. You don't know what caused what, right? So this metric correlation is a big problem if you are not using specialized tool. Now, what do we offer here? So we offer a couple of solutions. First solution is a software from Keysight, which you can put on real servers that would pretend to be a GPU in terms of data movements, right? It's not going to pretend to be a GPU in terms of actually training the model, but it's going to pretend to be a GPU in terms of data movements. So it will work with the network cards that perform hardware offload of RDMA traffic, also so-called Rocky traffic that we were talking earlier today about, so that you can figure out how your network and the network cards perform all together. And you don't need a GPU on such a server, right? So it's very handy to have that in your lab. It costs less. And it covers this gap that I was describing where the metrics are not correlated. Now we actually know what's happening in the system. We know what do we ask the network card to do. So when it does the job, we can understand if the job was done correctly or not on every single network card and every single data movement level. Right? You can also put that into a server where you have GPUs, so like in production. So if you're renting GPUs from the cloud, fine, just put them over there and experiment to find out if you can, where the problem is. Now, this solution is sometimes, have gaps where, for example, if you don't know where the problem is it a network card or a network? It can hide it because we are operating on the level of the software. And then also, if you're planning to put a new generation of network fabric so that when the new generation of GPUs come ready, the network is already tested, right? It's hard to do because you don't have these new servers with the high performance network cards. So what do you do in that case? So for that case, we have a second solution that we use with exactly the same Key Data Center Builder software, but instead of using real servers with the network cards, we emulate those network cards using our Keysight 81 traffic generators. So those traffic generators, they are capable, every single port of them can emulate one or more Rocky network cards. Those are DMA capable network cards, so that we can stress out the network now, pretending it has a bunch of NICs and GPUs behind them connected to it. And so that's how you bridge that gap for testing the new generations of the networks before the new generations of the GPUs become available. And we're also able to see very low-level details on every single packet that way. So there is no this hidden area between the NIC and the network. In that case, if you want to test the network itself, this is the best solution. All right. Now, what is the user actually sees when they use this product? So we have two applications for them. So the first is collective benchmarks. It's been around for almost a year. So it's pretty mature now. There's plenty of customers who use that. And I'm going to demo that product to you today, that application. And then earlier this month, we announced the workload emulation product. And yeah, we had the first live demo of that during the OFC conference earlier this month. So how do they differ? So the collective benchmarks application, what does it do? When you have an AI workload that is, for example, you are training a model, it uses collective operations. This is a terminology to move the data between the GPUs, right? And it does it over and over again, many times, millions of times. So if you want to benchmark a collective operation, right, you are zooming in into a single transaction that happens between thousands of GPUs, right? And what your objective here is to make sure that all the parameters of the network and the system are fine-tuned in a way that the network utilization can be as high as possible so that this collective operation can finish as fast as it can, right? So you narrowly zoom in into the performance of that data exchange between the GPUs. The workload emulation, on the other hand, takes into account the fact that, well, GPUs that not only move data, they also compute. That's the point, right? And there is a dependency between how much you compute and then how much data you're going to move, and sometimes those go in parallel. And so in reality, it's not necessarily important to always achieve the best possible performance for all types of collective operations, because a lot of them are sort of hidden behind compute, so it doesn't really that important to get the very best performance. What you need to know is what's the critical path in your workload, what are the things that are actually slowing it down, right? And so if you optimize that, and essentially the key terminology there is exposed communication time, is the time that GPUs really have to wait for the data movement to finish. So the workload emulation allows you to identify that critical path and do steps to optimize it, right? And then to finish up that part of the presentation, Keysight Kai Data Center Builder is a part of the larger portfolio that Keysight has. It's called Kai Solution Portfolio. As you can see, it spawns from solutions focused on testing elements that go into the servers, the compute part, where we test memory, where we test PCIe, CXL, where we help you design new silicon. We also have solutions that test cables, transceivers, interconnects at speeds of 100 gigabits per second, 1.60, and further. And then we spoke about the network part, right? And then the power part, of course, is very important. You want to understand how all the choices you can make in your design can influence the power consumption and heat dissipation.
Under your power consumption, do you also take into account cooling?
Yeah, of course, of course.
Of course.
I mean, when you consume power, right, you have to cool, essentially. Yes. So that's the thermal loading. Yep.
Do they still measure it in PUE?
PUE?
PUE. Now you're going to make me what it is. Power usage.
Don't ask me about that too much. Okay. I'm a network guy, right? Okay. So. All right. So. Okay, so what's coming next is the demo of the Kai Data Center Builder. So I'm going to talk about our data center fabric test methodology. Essentially, that's the way how you can test our product to get the best performance of your fabric. And specifically, I'm going to show you how to fine-tune DCQC and congestion control. This is a voodoo magic for a lot of people, and so I have an Easter egg for you. Okay.